Hello guys, I'm Alukosha Enoch. Welcome to my math tutorial class on matrices and determinants. In this tutorial section, I'll be considering the following content under matrices and determinants. First, basic concept, then addition and subtraction of matrices, matrices multiplication, transposition and special matrices, then determinant of order 2, third order determinant, simultaneous equation, the adjoint matrices, or better still adjoint matrix and the inverse of a square matrix, a matrix method for solving system of simultaneous linear equation in two variables. And if you look at this question now, I'm not sure we are good yet to solve this type of problem. So before we get started with the question here, I need to take you through board work on matrices and determinants. So guys, let's get started with matrices and determinants. Okay, from the beginning, guys. Okay, that's a good one. Okay, matrices. So I'll give you the content of matrices, matrix addition and multiplication, inverses and determinants, then transformation. Transformation, okay, don't worry, we'll talk about that later. So a matrix, okay, plural matrices is a rectangular array of numbers displayed in rows and columns inside a large set of brackets. So one use of matrices is to organize data clearly. And for example, the number of people that attended an exhibition over one weekend can be arranged in a matrix. So you can see here now, we have number of men and women, then children, and on a particular day, Saturday and Sundays. Okay, so you can represent this data in matrix form. Okay, this is 1 2 3 3 by 2 matrix, number of rows by number of columns. So you write the number of days, this in column, this is column wise, okay, and this row wise. Okay, so this is a 3 by 2, okay, a matrix. Because it has 3 rows and 2 columns, it contains 6 elements or entries all together. So what are the elements? 1 2 3 4 5 6. Okay, so a matrix A element can be identified as an element Aij, where I represents the rows and J represents the columns. Okay, and give the value of the following element of matrix. Guys, let me quickly um explain some basic concepts here. Let me just use my print screen now. Okay, guys, this is, if you are very good, if you are familiar with Excel, this is row 1, row 2, and row 3. Okay, so can I just put there R1, R1, R2, R3. So that's row 1 2 3. And let me change the pen now to, let me change the color to blue. This is column 1. Oh, sorry about that, let me just use line. So this is column 1, this is column 2, and this is column 3. So I'm going to tag that C1, C2, C3. So this is C1, and this is C2 and C3. Okay, so let's get started with the tags now. So A33, that is the element, because this is a set and these are the elements in the set. So I should go for element in row 3 and column 3. So this is row 3, this is column 3, and this here is it. So that is 11. Then let me go for this one now. A32, this is row 3 here, then column 2. So that will be 5. A11, that is row 1 column 1, and that is 6. Then A21, that is row 2 column 1. This is row 2 here, then column 1. So that will be 1. So that's how to complete that task. Okay, next. Okay. Okay, now types of matrices. Okay, I recognize. Okay, let me go back to that type of matrices. So press each type of matrix to see description and some examples. So I want to give you different types of matrices now. So let's see what a row matrix look like. So this is a row matrix, is just a single row, 1 5. The element here, 3 entries, 1 2 3 4, 4 entries. A single entry, 1 2 3 4 5 6 6 entries. But this is just row, a single row matrix. So it's row, just a row matrix. Okay, so let's check column. And you see column, this column vertical way, this is a column matrix. How about null or zero matrix? Okay, a zero matrix is a null matrix contains 0 entries. So all the entries in zero matrix are 0. Okay, that if this is a because we have 3 rows by 3 columns, so this is a square matrix. Okay, but forget about that, we're going to talk about that later. And this is also a null or zero matrix, because all the entries there are zeros. How about diagonal matrix? A diagonal matrix is a square matrix and where all entries are 0 except those are the leading diagonal. So if you look at the leading diagonals, and you have counting numbers here, but aside the leading diagonal you have all the entries are 0. Similarly, same thing here. And finally, let's take a look at unit identity matrix. And a unit identity matrix, a unit matrix or identity matrix is a diagonal matrix whose leading diagonal entries are 1. So all the diagonal entries 1 here, all the elements 1. So and this is unit or identity matrix. Guys, this is video, you can pause and take a look at it again. Okay, so the next content here now is how to complete addition and multiplication of matrix. Okay, so two matrices can be added or subtracted if they have the same dimension. Okay, so add each corresponding element from both matrices to get the resulting element. For example, if you take a look at this one here, let me just quickly take my print screen again. So and let's complete this task. So this is addition of matrix. I will just walk through this, then I will use my board work to complete the remaining tasks. Okay, so now you just, what you have to do now is to just add corresponding elements. Okay, this is a11, that is row 1 column 1, and this is a11, so you add. Okay, this is a this is row 2 column 1, so this is a21, like that. So you just add corresponding elements like that. So we have to go with that now. 6 plus 12 will give us what? 18. Okay, then you have minus 2 plus 1, that is minus 1. Then you have 8 plus 2, and that is 10. So you see that addition, matrix addition is quite easy when you add. Then 5 plus 4, that is 9. 13 plus minus 3, that is 10. 17 plus 0, minus 17 plus 0 is minus 17. And that's how to perform addition of matrix. Okay, so and let's take it, and that's what we have there, and that's it. Okay, guys, this time around, let's just go through that adding and subtracting matrix, and the same way you perform addition, the same way that for if you want to do subtracting matrix now, that will be 5 minus 1, then 0 minus 0, 1 minus 0, then 2 minus 2, like that. So let's take a look at the answers, not such as not to waste much time. Okay, so you can just take a look at that and confirm that the solution is correct. You can pause the video to confirm the solutions. Everything is correct, guys. Let's just go ahead. We have a lot to do. So which matrix when added to an m by n matrix result in the same m by n matrix? So that should be identity matrix. But let's take a look at it. So to add two matrices, they must have the same dimension. So the matrix must also be an m by n matrix. So mean that they should have the same dimension. Okay, so the additive identity should preserve the original matrix when added to it, therefore it must be a 0 matrix. Okay, so for example, don't forget that 0 is additive identity. Okay, for example, 2 plus 0, if you are to add integers, okay, or whole numbers, when you add 0 to any whole number or integers or any real number, and the identity of the real number remains the same. So the same thing is applicable with 0 matrix. Okay, so that's that. So the additive identity of m by n matrix is this the m by n 0 norm matrix. Okay, so a matrix can be multiplied by a single value, a scalar. Okay, so simply multiply each entry in the matrix by that scalar to get the resulting matrix. Okay, for example, if you look at the scalar product here is 3. Okay, so when you do 3 times 7, then you get equivalent entry here, then 3 times 5, like that, and that's how we are going to complete that. Okay, so use 3 to multiply each element in the matrix, and that's how to go about scalar multiplication in matrix. Okay, so guys, this video you can pause and just make sure you get it right. So what about this one now? Here I have 5 times 3 15, 5 times 11 55, 5 times 2 10, 5 times 1 5, then minus this. Then since you have this, you can now take away the corresponding element. 15 minus 1 to get the entry there, 10 minus 2, and so on and so forth, and we end up with this. Okay, so two matrices A and B can be multiplied, but only if the number of columns in the matrix A equals to the number of rows in the column B. So that is it. So the number of columns must be equal to the number of columns before you can perform a multiplication in matrices. Okay, for example, list all possible product pair from the matrices below. Don't forget that the rule is column should be equal to row, and number of column here is 2 1 2. The number of row here is 2 1 2. So A by B is possible. You can multiply A and B. But if you look at this one now, the column here is 1 2 and the row is 1 2 3. So it's not possible to multiply A and C. You cannot have A times C. Okay, then if you look at here now, I have 1 2 and then here I have 1 2. So the number of column here is equal to the number of rows, so A by D is possible, and so on and so forth, guys. You can just go ahead and take a look at it. We have a lot of questions to complete, guys. So to multiply two matrices, perform the dot product on the row and the column. So let me quickly teach you how to do this now. Okay, now guys, this is a good one. If you want to perform let me just take you through this now. So don't forget that you row multiply by column. That's how to go with matrix multiplication. So you multiply row by column. So you take the first row, multiply by the first column, and that's okay. So this will be 1 times 4 plus 2 times 5 plus 3 times 6. Again, 1 times 4 plus 2 times 5 plus 3 times 6. So let's take a look at it now. Okay, that's that, and we end up with that matrix there. So for larger matrix, start with the first row and the first matrix. So let's just take a look at this now. Let me quickly complete this one for you, and I will take this one as a sample problem for multiplication, and so that we can quickly go ahead with a lot of tasks, guys, to complete. So what I'm going to do now is don't forget, is this matrix possible? Yes. The reason being that the number of column here is 2 and the number of row is 2. So now just watch what I'm going to do now. So you fix the first row now. Oh, sorry, better so fix the first column. So the rule is states that you multiply row with column, row by column. Okay, so this is the first row. You complete the task for the first row before you go to the second row. So my answer, I'm going to have my answer here. So I'll get my answer here now. Okay, so here I'm going to have row by column. This is the column now. So I have no business with this second column here. So I'm working with this. I don't have anything to do with this one here. Okay, so 12 times 10 plus 7 times 13. So 12 times 10, that is 120. Okay, plus 7 times 13, guys. I need to use calculator there. Okay, I'm not lazy, guys. Okay, 13 times 7 is 91. So that will give us the first entry. So that will be something like A11 column 1 row 1, row 1 column 1. Okay, then you do the same thing here also. I'm through with this row 1 now, so go for the next now. That is R2. I'm through with R1, so the next row is R2. So you perform the same task with R2 on C1. So 5 times 10 is 50. 5 times 10 is 50. Then plus 6 times 13. So 6 times 13, or better still 13 times 6, the same thing, guys. That's 78. So I'm through with R2. Then I'm repeat the same process for R3 against C1. So 2 times 10 is 20. Then plus 3 times 13. So I need not to use calculator for this guy. Okay, so that is 39. So guys, this will give me my row this everything about row 1 column column 1, then row 1, row 2, row 3. Okay, so then I'm now going to repeat the same process for this start now. So I don't have any business with this now. So let me just do as though I'm going to cancel this. So I have no business with this now. So I'm going to repeat the same task with this now. So let me use another color now. So let's do this. So I want to start the same process here now. Why do I do that? Okay, let me just, I'm going to repeat the same process here now. Okay, so let's get started now. So I can just complete my stuff here. Okay, so R1, so this is C2, don't forget, fix C2 now. I'm done with C1. So R1 times C2, R2 times C2, then R3 times C, like that. Okay, so let's get started now. So 12 times 15 first. 12 times 15, and that is 180. So 12 times 15 is 180. Okay, then plus 7 times 9. So 9 times 7 is the same thing as 7 times 9, and that is 63. So I'm done with R1. Then do the same for R2. 5 times 15, then 6 times 9. So 5 times 15 equals to what? 5 times 15 is what? That is 75. So 5 times 15 is 75. Then you now do 6 times 9. So plus 6 times 9. 6 times 9 is what? 54. Okay, so that's all. Then finally, do the same here now. So 2 times 3, 2 times 15 rather, that is 30. Then plus 3 times 9, and that is 27. So guys, and we are through. So what's the final answer now? So the final answer is 1 120 plus 91, 120 plus 91, and that is 211, 211. Then 50 plus 78, 50 plus 78, and that is 128, 128. Then finally 20 plus 39, 20 plus 39, and that is 59. So check the second one, 180 plus 63, and that is 243, 243. This one here I have 75 plus 54, 75 plus 54, and that is 129. And finally I have 30 plus 27, 30 plus 27, and that is 57. Okay, so that's how to go about that. So guys, this video you can pause and get to and take a look at it again. So let me just use my board work to complete the same task now. So that's the solution, guys. Next. Okay, so that's what we have there, and you have that. I explained everything there, and we have our final answer there. Okay, so this I'm not going to waste my time with this, but the this is number of column here 1 2 3, and number of row here is 1 2 3, so it's correct. So you just do 3 times 6 plus 4 times 9 plus 3 times 0. Then you get the first element. Then you do 2 times 6 plus 4 times 9 plus 6 times 0. Then you get the next element. So let me show you the answer now. So that's what we have there. So 18 plus, and what's the answer there? 54. So because of our time, guys, this board work, and I will show you where to access this board work immediately after the section, so that you can download and complete. There are a lot of exercises here, guys. Okay, so what happens when you multiply this? Okay, do you need to, just take a look at that. Okay, so that's that, and you have that. So this is identity matrix. Don't forget, just like you have a multiplicative identity in integer 1. So when you use 1 to multiply any number, the identity of the number remains the same. So the same way when you use multiplicative, when you use apply multiplicative identity on a particular matrix, the matrix still remain the same. Okay, so inverse and determinant. Okay, I don't know if I'll be able to manage my time. So I'm not going to run through this, guys. This board work, guys, just go ahead and get it. I'm going to apply this determinant, and in the next question I'm going to solve. So this says that there are two matrices. Now when you multiply, the two matrices are said to be multiplicative inverse if you multiply the two matrices such that your answer is identity matrix. So when you multiply the product of two matrices, if the answer is identity matrix, then the two matrices are said to be multiplicative inverse of each other. Okay. There is special value known as determinant. I'm going to teach you how to do this, but I'm going to apply it because of our time. Okay, so we find the determinant of that, and that is that board work. Then how to find inverse. I'm going to apply inverse too. Okay, and inverse of a matrix, of a given matrix, is 1 divided by determinant multiplied by the adjoint, okay, of the matrix. So adjoint is transpose of the cofactor. Adjoint is transpose of cofactor, but don't worry, I'm going to explain that. I'm going to apply it to solve this problem. Then how do you know if a matrix has no inverse? If the identity does not exist, or better say if the identity is 0. For example, if you multiply this one 4 by 4, okay, let me quickly teach you how to find identity, even though I'm going to apply it. Oh, why did I do that? Okay, I'm sorry about that. From current. Okay, okay, so this where yeah, okay, so print screen. Okay, so let me quickly teach you how to find um, determinant of a matrix. So for example, determinant of this matrix, okay, 4, 2, 8, 4. So the first thing is just to add the operator plus minus here. Okay, guys, because of our time, I think I'm going to divide this video into two sections. So I'll go to have part 1 and part 2. Because the way I'm looking at it, I may not be able to complete the task in single because of the possibility, the size in order to upload it on YouTube. Okay, so now determinants now. So what you do is just you multiply the diagonal value. So 4 times 4, then you get your answer there. 4 times 4 is 16. Don't forget I add this operator plus minus, then minus 2 times 8, that is 16. So 16 minus 16 is 0. So in that case, anytime the determinant of a matrix is 0, then the inverse, such matrix has no inverse. So that's it. So why does the matrix B have no inverse? Because the determinant equals 0. Okay. So guys, don't forget, I think I'm going to divide this into two sections. I pray, I don't know. Okay, transformation. Okay guys, what I'm going to say here now is I will not be careful to complete this transformation stuff here. The reason being, let me quickly show you something here. So we have I already did a video on transformation matrices, so you can just go ahead and next. I think it should be number 3 or something. Okay, so I'm sorry about that. Okay, so I already did make a video on transformation matrix, guys. So just go ahead and type this URL, okay, and scroll down and get transformation matrix. So on that, then you'll be able to get that. Okay, so now let's get started with the question so that I don't need to divide this video into two equal parts. Okay, so at this point now we want to take a look at how to apply matrices and determinant to solving system of linear equation. Okay, so use matrix to solve this system of linear equation. Okay guys, the first thing here is you can rewrite your equation in matrix form. So don't forget that I have x and y. So you write the variable as a column vector, x, y. Okay, so x, y, those are the variable I'm looking for. Then multiply by, so you can now bring the coefficient out now. 5, 2, so it's column weight 2, so 5, 2. Then this one is 2 minus 1. The coefficient of x here is 5, coefficient of x here is 2, coefficient of y there is 2, and the coefficient of y down is a minus 1. Then equals to, the constant there is 25 and 1. Okay, so now what happened? Don't forget that when you have something like maybe 2x equals to 4, and you're looking for the variable x, you divide both sides by 2. Okay, so similarly here I'm looking for this variable x and y. Okay, because I'm looking for the value of x and y that satisfy the system of simultaneous linear equation in two variable here. So meaning that you use x, y as subject formula. So I'm dividing through by this. Another way, when you divide through, it means that you can rewrite it as 4 times. So you want to use times now, it means that 1/2. 1/2 means 2 inverse. So that's where the word inverse comes from. So meaning that the variable x and y, now if I were to solve this one now, what I'm just going to do is to go ahead and multiply the constant, the column vector of this constant here, by the inverse, because we are dividing by this. So by the inverse of this, so 2, 5, 2, 2 minus 1 inverse. So good. So at this stage now, we can now learn how to find the inverse of a given matrix. Okay, don't forget, before now I said that the inverse of a given matrix is transpose of the cofactor. Okay, so now but that's not true. That's not the complete definition. So it's not just so it's for example, let's a, I just want to use this a set. Okay, so because a matrix is a set with the following elements 5, 2. Okay, so let a be 5, 2 and 2 minus 1, and a is a 2 by 2 matrix. Okay, it's 2 by 2 matrix, it's a square matrix. Okay, so now I want to find the first thing If you want to find the inverse now, let's say the question asks you find inverse of a. I want to find a inverse. To find a inverse, by definition, a inverse equals to 1 divided by determinant of a, then multiplied by the adjoint of a adjoint, don't forget adjoint. Let me just put adj, or let me just put a asterisk because of my time. Because of my time, I'm sorry guys. So where a star is a adjoint of a, guys. Okay, so the first thing now is to go for a determinant of a. How do you find determinant of a? So determinant of 5, 2, and 2 minus 1. So how do you find the determinant? So determinant, I did that before now, so just put plus here and minus here, and go ahead and do the multiplication. So you cross it, okay? So 5 times minus 1, and that is minus 5. So this is minus 5, then plus minus 2 times 2, so that is minus 4. So the determinant of a is minus 9. So let's keep that. Determinant of a is minus 9 because I'm going to do something like 1 divided by minus 9 by my definition. So the next thing is transpose of a. So since this is a 2 by 2 matrix, transpose is very easy for in 2 by 2 matrix. So in 2 by 2 matrix, what you just do, transpose of the cofactor, or better say the adjoint of a. So the adjoint of a is such that you just swap this, so these two values you swap, okay? So minus 1 goes up and 5 comes down. That's it. So I have minus 1 instead of, so minus 1 against 5. Then secondly, just add negative to this diagonal. So instead of 2, you have minus 2, minus 2. So that is the adjoint. So I can now complete my inverse solution now. So let me just put there a star. That is adjoint of a, is that. And my determinant is this. So then to now get my a inverse now, finally, the value for my a inverse is 1 divided by minus 9, okay? Then into the transpose now, minus 1, minus 2, minus 2, and then 5. So that's all. So now what am I going to do now to get my xy now? Xy value from here. Let me just take this because I need to manage my board very well. Okay, so don't forget that this is what we want to, this is what we are trying to complete, the task we are trying to complete here. And I have this already, and here is it. I have it already. Sorry about that. Let me just take it here. So I have this already, this value here. So just multiply by that. So that's it. So now, so finally my xy, I don't know why I did. Okay, so xy, not a bad one. I just need to manage this, guys. So xy equals to, so I'm going to use 2, 5, 1. This is what, 2 by 1, okay? 2 row and 1 column. Then to multiply this. So this one now, let me just multiply out. Minus 1 times minus 1, so that's 1 over 9. 1 over 9. This one now, don't forget your scalar product. So minus 1 over 9 times minus 2, that is 2 over 9. Also, minus 1 over 9 times minus 2 here will be 2 over 9. Then finally, this will give me minus 5 over 9. So guys, I will just give you the final answer here, but I'm going to explain so that you understand better. You're going to use calculator to complete this because of the space I have there. Guys, don't forget, this is how to complete it now. So now what do we have here now? So you now go ahead and 25, because you don't forget that it is you fix the row to column. Okay, let me just quickly do that. So I have this column 1. Don't let me use blue. Let me just change the color so that you see what I'm doing now. So this is what am I doing? I'm sorry about that. It's row to column. Okay, so I'm just saying already. Okay, so this one here, let me just write it out. 1 over 9. Now that's what I have here. So you just use this to multiply because it's row to column. So the row should come, this one should come first. Okay, so just write out this now. 1 over 9. Then this is 2 over 9 here. That is the inverse matrix. Then this is 2 over 9 here too. And finally this is 5 minus 5 over 9. Okay, minus 5 over 9 here. Then multiply by, so your row matrix here now, 25 1. 25 1. So don't forget that you do row to column. So let me just quickly, and this is game over already. Let me use this here now. So you just go ahead and this is row to column. So use this one to multiply this down here. So I'm going to write the answer here. I don't know if I'll be able to. Okay, let me just try. So 1 over 9 times 25 over 9, that will be 25 over 9. 25 over 9 plus 2 over 9 times 1, so plus 2 over 9. How about the bottom one? 2 over 9 times 25 over 9, that will be 50 over 9. And similarly, minus 5 over 9 times 1, that is minus 5 over 9. So guys, just take your calculator to complete that. Take your calculator to complete that. You see that the value of x, when you sum that, I'm going to write my final answer here now. So the solution to this equation will be such that the value of x and y is what I'm going to write here now. So the value of x equals this, and the value of y will be equals to this. So what is x value? So if you complete that now, 25 over 9 plus 25 over 9 plus 2 over 9 will give you 3. Similarly, 50 over 9 minus 5 over 9, this is 5, guys, and this is 2. Okay, and that will also give you 5. So you can go ahead to try 5 into 3 plus 2 into 5 will give you 25. Similarly, 2 into 3 minus 5 will give you 1. So it is satisfied. Okay, so finally I don't need to I will complete the task now. Okay, it's just a long video, guys. Okay, this one here now, I think I should be able to, guys, matrices is quite I don't know. For me, if I have to choose between using matrices and determinant, guys, I'll just go with determinant. You're going to see what is going to happen now. Since I already taught you guys how to use matrices to complete system of linear equation in two variables, so this time around they asked me to choose either matrix or determinant, but I'm going to work with determinant so that you guys can learn how to use determinant to solve the same problem. So immediately I complete this one, you can use this same determinant to solve the first problem and see the beauty of determinant over matrix in solving system of linear equation. For me, the beauty. Okay, so now this question here now, because of our time, let me quickly read this. Smith family and John family are taking a trip to circus. Okay, I need to quickly do this. Let me use red because it will be clearer. Okay, so what I'm going to do now is in Smith family there are 4 adults. Okay, I'll use the variable I'm going to use here will be A. Then children I'm going to use C. Okay, so that's all. So because of my time, A and C, guys, just read through the question and you understand what I'm doing. So the first what I'm going to do there now, the first system I'm going to represent this one as a system of linear equation. So there I have 4A, that is 4 adults, plus 3C, that is 3 children, equals to guys, this is 47. You don't need to put the unit there. 47 pounds or euro, guys, that's a cup of Milo. I'm sorry about that. Okay, so and then equation 2, in John's family we have 2 adults, so that will be 2A plus 6 children, so that's 6C, and the total cost is 44, so I can write that as 44.00. Okay, so that's all. So guys, now the beauty of matrix now. The first thing I need the following parameters. 1, delta naught. Delta naught. Then I need delta A. I just use that symbol to represent, okay? Then I need delta C. So let me write that now. So I need delta naught. delta A from variable A, delta C from variable C, delta naught from constant because there is no variable here, so I just say delta naught, delta 0. Okay, so the first thing I'm going to calculate is delta naught. So delta naught means that I will work with this here. Delta naught means I work with the variable constant. I exclude this now. So and that's what I'm going to do now using determinant. So all I need to do here is just determinant. So determinant of 4, 2, then 3, 6. Guys, I'll be very fast because of our time. Just plus minus. So you can just confirm my solution. So you multiply this one by this, take away this one by this. So the determinant there will give you delta naught will give you 18, because that will be 24 minus 6. Yeah, I think I'm correct. 24 minus 6 is 18. Okay, then next, delta A. So delta A means that let me use blue this time around now. Let me just use blue so yeah, you see what I'm doing. So delta A means that I should exclude A coefficient and work with the remaining stuff. So I'm going to work with this here. I'm going to work with, since I'm excluding A, then the next variable is C, but I can't go like this. So since you are excluding A, they mean that you just exclude the variable. So you start with the constant, then with this now. So that's what you're working with now. So I'm going to find the determinant of that. So it's 47. Let me just make it bigger. So I have 47.5. I can exclude the 0. 47.5. Then against 44. So you express this as a column matrix vector. Okay, your matrix is okay too. Then A, because this is delta A, so you go with C. So 3, 6. So you go ahead the same thing, go ahead with the determinant. This multiplied by this minus this multiplied by this. So guys, just go ahead with your calculator and do that. If you do that now, this will be 176 minus 95. Yeah, so that should give me 81. So the answer here will be 81. Then finally, can I use another color now? Guys, time. Oh, I think no problem about that. So I think I'm happy that we complete this task. Okay, so this one delta C now. So this time around, meaning that I should exclude C coefficient, so I'll go with A, and I'm starting with A since A is the first column there. So 4, 2, then exclude C because I'm looking for C. Then you work with 47.5. Do you see the beauty of determinant, or the beauty of using determinant method? What you just need to do is just determinant, not about you are not finding cofactor, no inverse or anything. So that's a good one. So this is plus 4 times 44 minus 47.5 times 2, and if you do that, I think that should give me, oh my god, delta C should give me and I just do that. That is delta C, right? Okay, so that should give me 81. Okay, so I made a mistake there. Then I need to be careful. Why did I do that? So 47.5 times 6 is 285. So this is actually 285 minus 132. And so delta A is actually 153. So I'm sorry about that. So this 153 here. And this one here, let me just write it is 176 minus 44 times 4. Let me just confirm that. 44 times 4. Yes. Then 47.2 times 2. 47.5 rather. 47.5. 47.5 times 2. 95. Okay, I'm correct. So when you take away that, you have that. And this one here, let me just write it. That is 18 minus 24 minus 9 minus 24. I'm sorry about that. 24 minus 6. Okay, guys, and that's that. So what are the values we have here now? I have 81. I have 153. Then I have 18. So finally, what's the value of A? C. So A is delta A divided by A naught. And delta A is what? Delta A is 153, and my A naught is 18. So what is 153 divided by 18, guys? So 153 divided by 18, let me just quickly do that. 153 divided by 18. Yeah, I'm correct. So that is 8.5. So A is 8.5. Similarly, for B, let me just change the color now. For B, sorry, for C, I have that C, that is children, will be delta C divided by delta naught. So, and delta C is what? Delta C is 81. So 81 divided by 18. So what is 81 divided by 18, guys? 81 divided by 18, and that is 4.5. So guys, I will just confirm, I will substitute the four equation, guys, because time is fast spent, and that's that. Okay, so let me look at the first equation now. But anyhow, okay, or better still, let me just check second equation. So 2 into A, my A is what? 4.5, plus 6 into C, my C is 8.5. What am I doing? My C is 4.5. Sorry about that. uh, 2 into A, this is value of A here, 2 into 8.5 plus 6 into C, and my C is 4.5. So, and that, if you should do that, your answer should be what? 44. So let me confirm that, okay, and we call it the 2 into 8.5, close the bracket, plus 6 into 4.5, close the bracket. Good. So the answer is 44, guys. So that's the end of the tutorial for today's section. Thank you, guys. Please don't forget to subscribe to my channel, and guys, just go here, because that boardwork, there's still a lot there, and this is transformation matrix application that you can use it to complete the task here. Really, there is a lot of beautiful stuff here. So, and you can also access this boardwork here. You can access the boardwork via this test shop, my test shop. So just type test.com in your URL, guys. So guys, please do have a great day ahead, and have a nice day. Don't forget to subscribe to my channel, guys. Love you guys. Bye. Bye bye.